In this video, we'll continue our discussion of Chapter 1 of DiffyQ, Section 1, by verifying a few more solutions to DiffyQs. I want to do some of the weird ones so I don't leave you like you feel like you're completely lost going into the homework with some of these concepts. The big thing here is I wanted you guys to see C1, C2. We can have multiple constants. And then this thing. Okay, x of t, in this case, t is the independent. X is the dependent. T is the input. X is the output. So X is not the input in this one, it's the output. All right, so we're going to verify just by taking derivatives and plugging it in. So make sure you're leaving plenty of your room. We really don't want to bunch any of this up. All right, so X equals, and I don't need to put T. You can. All right, I'm writing kind of small, trying to stay neat, telling you that that is the key to all this. Okay, X prime. All right, if I take the derivative, it's going to involve a chain rule, getting a 2 out of that 2t. So I'm going to get 2 c1 cosine 2t plus, okay, and then this is going to get cosine derivative gets me a negative, sine 2 comes out. So I get negative 2 c2 sine 2t. And then x double prime, I need that, right, all the way up to that. I get negative, the 2 is going to come out, making a 4 c1 sine 2t. This is still negative 4c2 cosine 2t. All right, so those are derivatives. I like to write this like left-hand side business because it's still formal, and I don't have to write everything out, and I don't have to be as particular. Okay, so what I mean, okay, I'm going to do x squared plus 4x, and then I'm going to just put an equal sign and then work down. So equals, okay, the second hand derivative, or the second derivative, not hand. I think that probably means something else. Is that right? See if I can shrink this down. Yeah, sorry, I know you can't do that unless you're using a tablet. Okay, and then plus 4, and it's times, and then I get to cheat again. So I'm gonna copy and paste that there. All right, I just want to do it so my video is nice and pretty. Okay, I get that. Now I get, writing that out. I'm gonna get the same thing up front. And I'm gonna cheat a little bit here as well. Oops, not delete. I'm going to duplicate it because that 4 now can distribute. Yeah, I don't think I get to do it. Okay, so I don't get to cheat. All right, let's write it out. I'm going to zoom in and write real small. So I get negative 4 c1 sine 2t minus 4 c2 cosine 2t plus 4 c1 sine 2t plus 4 c2 cosine 2t, and that equals 0, which equals the right hand side. There we go. So I would like this line written out, just because when you're verifying stuff, you need to show the steps, because if not, then you could justify skipping any step and you could start here and be like, oh, 0 verified, I'm good. No, you got to show a little bit. So please just show me enough work. Also, show you can mess up just one little negative at the very beginning. This is actually my second time recording this video because this practice exercise 2, I made a small mistake and had to go back and fix it. And it just took a little bit more time. So be very careful, write out everything, write neat. This is the way you need to communicate this to me. It's going to be better for you anyway. It's just very hard for some reason, very hard to convince students. And I mainly teach future engineers and physicists. Physicists aren't so bad, but engineers don't want to write things down. You want to write things down for this. It's going to get so like involved. You need the partial points. Okay, practice exercise 2. Okay, this one looks pretty gnarly. So what we're gonna have to do is, I want to talk about something real quick. And this, if you're in Calc 3, this idea really is the key to like the back half of that class, the back third maybe. Um, okay, so let me show you. First things first, I'm gonna tell you guys when I take the integral of f of t dt, we're gonna call this capital F of t. Right. So that also means that if I take capital F of t and I take its derivative, I get f of t. Right. So the integral of little f is big F. Okay. So I want to remind you guys of something. D dt, I'm going to take the derivative of an integral from any constant, a, up to x, all right? Yeah, but I don't want you to put t, I want you to put x. Yep, sorry, almost made that mistake. So d dx here, there we go, times this derivative, or integral. Get that out there. Okay, here we go. So I'm taking the derivative of this integral and we're going to work it out because I want you guys to see it. Some of you guys may already know it, which is fantastic. I'd be very impressed. So d dx, I'm going to leave that alone and go ahead and take my integral. My integral is going to be capital F of t. And then I know I have to plug in a and I have to plug in x. All right, if I keep going with this, okay, I keep my d dx. I'm going to go ahead and plug these in. F of x minus f of a. And then if I take the derivatives, I know that the derivative of big F is little f, but now it's in terms of x, not t. And then this is just taking some constant a and plugging in to big F, which is going to be a constant. So that just goes away. So the big kicker that I think will help, I know it helps in Calc 3 with understanding some of those core ideas at the end, that d dx of 0 to x f of t dt is equal to f of x. Okay, very powerful thing here, right? All right, so let's try this problem. The reason I went over that, you can tell I have a y here with an integral in it, and I'm going to have to take at least up to the first derivative, thankfully not past the first derivative, to verify this thing. Okay, so leave yourself some space because we're going to have to do the product rule. Okay, so I get the square root of x from 4 to x, so you can see the similarity of what we were just talking about, square root of t dt. Okay, and then y prime. Now I write out these rules because in Calc 3 we start doing partials, and when I do partial derivatives, I start messing these up. So I'm just so used to writing them out. So I'm going to write out the rules. This is the derivative of x to the 1/2 power times just the integral that's there, the second function, dt, plus, okay, I keep the x to the 1/2, and then now I take the derivative of that integral, and this is the reason we talked about it. There we go. Okay, and if I keep working that out, make sure you're leaving some room because we're going to still have to verify. Okay, this derivative of x to the 1/2 is 1/2 to the x to the negative 1/2, right? Bring it down, go down by 1, times that integral, plus x to the 1/2 times, and then remember this is nice and easy. It doesn't matter what that 4, if it was a 0 or 10 or 27, doesn't matter. It's going to go away with that derivative, and it's just going to leave me this function with cosine of x, and then on the bottom it's just going to be square root of x, and that works out really nice because this cancels with that. So I get cosine x plus 1/2 x, let's go ahead and just change it, plus square root of x over 2 times that integral, and that's our second derivative. Okay, so it cleaned up okay. All right, so left-hand side, I'm gonna write small just in case I need it. Left-hand side. Since it's kind of complicated up there, I'm going to go ahead and write that what they have out. Okay, this is equal to 2 times uh, x. I leave that alone, times the derivative, which is going to be, let me fix that brackets, bother me. Cosine of x, right? Small, we're going to fit it. Square root of x over 2, 4 to x of that integral, and then minus, and then it's just the integral with the square root of x out front. And that dt on bottom would make things very interesting. Okay, so if I multiply this out now, I get 2x cosine x. And then we should write this out. just so we have it. Okay, the 2's are going to cancel when I distribute. And then we're going to get an x. So what's going to happen here? Right. Oh, you know what? Silly little mistake here. This, where is it at? Do you see that that's a -1/2? So this is what I'm talking about. These little mistakes can get you. So I'm going to fix this as a half x to the -1/2. And that's going to fix our issue here that I just was like, oh, what's going on? All right. So 1/2 x to the -1/2. And then I accidentally erased that. There we go. So now when I multiply, 2's cancel. And then I'm going to get a plus and then x to the first times x to the -1/2. Remember, I just add. So I get x to the 1/2 times the integral 4 to the x cosine of t square root of t minus, and I'm going to go ahead and change it just so it matches so we can see it. That's going to cancel with that middle term, leaving us with what we need. I'm going to go ahead and do that since I'm at the bottom of the page. I forgot a DT in here as well. So that's why I don't like to shove things in there. I think I just dropped a half in this case, but that goes to show you how easy it is to just mess that up. One little negative caused it to be wrong. And that's why this course, it's not my favorite. I like it because it's calculus and I prefer to teach this in my algebra courses that I have to teach. Um, but I don't like it because it feels like coding. It feels like one little, it doesn't work in the end, and then I'm like, where is the mistake? And I go in and have to look and look and look and find the mistake. My coding experience, which is extremely, extremely slim, that's all that felt like. So, anyways, I'll stop talking about that. Okay, cool. My advice: write small, write neat. Okay.